AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it.
So the biggest story in AI this week, it actually isn't a massive technical breakthrough. It's actually a massive reality check on pricing and enterprise adoption.
Yeah, a huge reality check.
Right. So we've fed a huge stack of this week's industry newsletters, corporate payment data sets, and hardware supply chain reports into our deep dive today. And really our mission here is to figure out if the AI hype bubble is popping or if the technology is just finally maturing into something, practical.
Wait, something we can actually use.
Exactly.
Yeah.
Like, are companies finally realizing they don't need a literal supercomputer to do basic everyday tasks?
Well, I mean, the data indicates a hard pivot here. The market is adjusting violently right now.
Violently.
Yeah, violently. The cost of what the industry calls, frontier intelligence, like the absolute most capable models out there, it is plummeting.
Wow.
And at the exact same time, because the power grid on Earth is it's maxing out, the physical infrastructure needed to support all this compute is quite literally heading to space.
Okay, space. That is, we have a lot of ground to cover today.
We really do.
From orbital data centers to, international silicon smuggling rings.
Oh, yeah, that story's crazy.
It is wild. So let's dive into what we're tracking in this week's deep dives. And just a quick reminder up front, if you want to cut through the AI noise every single week and actually understand how this tech impacts your daily workflow, make sure you hit subscribe to the AI Verge.
Yes, absolutely hit subscribe.
Yeah.
So let's start with the macro picture here, right? Because the economics of AI are just fundamentally shifting right now.
Shifting how, exactly?
Well, according to the reports in our stack, OpenAI just slashed the prices for its highest performing model, GPT 5.6L, by over 20%.
See, a 20% price cut on a flagship product, that is a massive
That's
haircut.
huge.
The specific numbers we were looking at, they show they've dropped it to $4 per million input tokens and $20 per million output tokens.
Right, which is...
And that undercuts their biggest rival, Anthropic, pretty severely, right?
Oh, severely, yeah. Because Anthropic's top-tier model right now, Fable 5, is sitting at $10 for input and $50 for output.
Wow.
So Sol is now vastly cheaper. It's even undercutting Anthropic's older, their Opus 5 model.
That is wild. But okay, the pricing split between input and output tokens, this is where the mechanics of this get really fascinating to me.
Oh, yeah, the math is weird.
Right. A lot of people see those two numbers, like $4 versus $20, and they wonder why the AI costs literally 5 times as much to write text as it does to read it.
Yeah, it's a super common question.
I've actually wondered that myself.
Yeah.
If a token is just a chunk of a word, why does the direction even matter?
Well, it all comes down to how the silicon actually processes the data under the hood. When you hand an AI a massive document, right, say like a 100-page PDF, that is your input.
Yep.
The graphics processing units, the GPUs, they can read and process all those input tokens in parallel.
Like all at once?
Exactly, all at once. They just blast through the whole document simultaneossly. That is computationally very cheap. But output tokens, on the other hand, they are generated autoregressively.
Wait, autoregressively, meaning it predicts the next word,
Yeah.
right? Like one at a time.
Correct, yeah. It predicts a word, then it has to take that new word, add it to the context window, and run the entire massive neural network again just to predict the next word.
Oh, wow. Every single time.
Every single time. It is a sequential, step-by-step process. The GPU actually has to load the model's entire weight matrix from its memory for every single token it generates.
So it's moving a ton of data constantly.
Yes. That memory bandwidth bottleneck is exactly why output is so incredibly expensive compared to input.
Okay, so let me see if I get this. So input tokens are like giving the AI a printed map to look at all at once, right?
Yeah, perfect analogy.
But output tokens are like forcing it to drive a car blindfolded, and it's stopping to recalculate the route at every single intersection.
That is a fantastic way to visualize the computational drag there. And, it explains why this 20% price cut is sending literal shockwaves through the developer community right now.
Because it lowers the barrier.
Exactly. Cheaper output tokens are the key constraint that finally unlocks these complex agentic workflows.
Okay, let's unpack that term agentic, because it gets thrown around a lot in these source reports, and it feels a bit buzzy.
It does.
What does an agentic workflow actually look like in a practical business environment?
Right. So up until now, we've mostly treated AI like a really smart search engine, right? You ask
Yeah.
a question, it gives an answer, one prompt, one response.
Sure.
An agent is fundamentally different. It's
Oh,
designed to act on your behalf by looping its own logic.
Clipping its own logic.
Yeah. So imagine you want an AI agent to research a competitor's financial filings, draft a summary report, check its own facts against a secondary database, and then format it for an email to your boss.
Right, so the model can't just do that in one shot.
No, not at all. It has to think through maybe 100 distinct sequential steps to get there.
Wow.
It generates a search query, reads the results, evaluates if the results are actually good, rewrites the query if they aren't, drafts a paragraph, critiques its own paragraph, and edits it.
That is a lot of output tokens.
Exactly. Every single one of those internal loops consumes output tokens. So if an agent has to think through 100 loops before it ever shows you the final result, a 20% discount on those output tokens, I mean, that is the difference between a cool weekend prototype and a profitable product you can actually deploy at scale.
I see the mathematical value for developers, for sure. But let's look at the enterprise side of this, because I gotta say, highly skeptical of OpenAI's motives here.
You don't think it's out of the goodness of their hearts?
Definitely not.
Yeah.
And this brings us to the corporate payment data we pulled from RAMP. The data shows businesses are actively avoiding those super expensive top-tier models.
Right.
Like, Fable 5 only makes up 6% of total token spend right now. Companies are voting with their wallets, right? And they are choosing cheaper, smaller, more efficient models.
Because they are realizing they don't need a trillion parameter model just to, summarize a Tuesday marketing meeting.
Right. So I have to ask, is OpenAI really cutting prices to empower developers?
Mm-hmm.
Or are they just reading the tea leaves because enterprise budgets are drying up?
It's a fair question.
It feels like they are selling Thor's hammer on the discount rack because literally nobody wants to pay premium prices to kill a fly.
I love that. And look, the RAMP data suggests it's a bit of both, right? But you're touching on the real macro constraint here. Capability at all costs is over.
Finally.
Yeah. We're firmly in the ROI era of AI. CFOs are looking at their massive cloud bills, and they're demanding actual returns on that investment.
Which brings us perfectly to our next story, actually. Because even with these price cuts, the sheer cost of renting intelligence via API is forcing massive companies into DIY solutions.
Oh yeah, the Thomson Reuters news.
Yes. Thomson Reuters just built its own proprietary legal AI model, which they are simply calling Thompson.
And the methodology behind how they built this is what really stands out in the research here. They did not start from scratch, right? They didn't train a model on thousands of GPUs for a year.
Okay, so what did they do?
They took an existing open source model, Alibaba's Quinn, and they used it as a foundational base, and then they fine-tuned it on their own decades of proprietary legal content.
Oh, wow.
Yeah, we're talking about the deep archives of Westlaw, Practical Law, Reuters News, all of it.
But the sources note it still cost them $40 million in talent and compute to build this. Honestly, $40 million sounds like a massive capital expenditure.
It is a lot of cash.
Right. So who really benefits here? Is this actually a useful tool for legal professionals today? Or is it just a corporate vanity project to boost their stock price?
No, it's incredibly useful right now. According to their internal benchmarking, this Thompson model is actually scoring higher than the absolute best frontier models.
Really? Better than the big ones?
Better than the big ones, like Claude Opus 4.8 and GPT 5.5, specifically in things like legal reasoning, contract analysis, and factuality.
That's impressive.
It's beating the giants at their own game in this very specific domain. And to address the $40 million in the current landscape of AI infrastructure, that is a total bargain.
Okay, a $40 million bargain. You're going to have to justify that one. Are you saying relying on OpenAI's API is like paying a premium for every single drop of municipal water? Whereas Thomson Reuters just spent $40 million to drill their own deep water well on their own property.
That is the exact economic mechanism at play here. Think about the massive scale of Thomson Reuters, right?
Okay.
If they integrated a frontier model via API, they would be sending millions of complex legal queries spanning massive documents to a third-party server every single day.
Right. The token cost would just be astronomical.
Astronomical. And they'd be renting that capability forever. By fine-tuning their own model, they own the intelligence layer of their business outright.
Let's get into the mechanics of that fine-tuning, though. Because why couldn't they just use RAG, retrieval augmented generation?
Good question.
We talk about RAG all the time on the show as a cheap way to give an AI specific knowledge. You just paste the legal document into the prompt and say, hey, answer based on this. Why spend $40 million to alter the model itself?
Because RAG has hard limits when it comes to deep structural reasoning.
How so?
Well, RAG is essentially giving the AI an open book test. It can look up a specific statute if you provide it in the prompt, right? But legal reasoning requires understanding the nuanced syntax of law, how different precedents interact, the specific cadence of legal arguments.
So ARG doesn't teach the AI how to think like a lawyer. It just gives it a law book.
Precisely. Fine-tuning, on the other hand, actually adjusts the billions of synaptic weights inside the neural network itself.
Oh, I see.
So by running millions of Westlaw documents through the Quen base model, they are fundamentally altering the model's internal circuitry to heavily favor legal patterns.
It changes how it thinks.
Exactly. The model internalizes the domain. That's why it's beating the massive generalized models. A general model is trying to be a poet, a coder, and a doctor all at once. Thompson is just a really, really good lawyer.
Okay, that makes practical sense. They own the domain data, so they own the model. But building and running these models, even specialized ones, it requires immense physical infrastructure.
It really does.
And apparently, Earth is running out of room for it. Which brings us to arguably the wildest update in our stack this week.
Oh man, this story.
Right. SpaceX is officially partnering with Nvidia to put data centers in orbit.
Yes. The Starmine Data Center Initiative, this is just a fascinating engineering pivot.
It sounds insane.
It does. They are aiming to get the first racks into orbit by the fourth quarter of 2027, and they're utilizing the new Vera Rubin NVL-72 server racks from NVIDIA.
Okay, I have to admit, I am highly skeptical of this timeline and honestly the entire concept. I distinctly remember Sam Altman just earlier this year calling space-based data centers ridiculous.
He did say that, yeah.
What are the actual logistics of this? I mean, space is a vacuum. It has zero gravity, extreme temperature swings, cosmic radiation. How on Earth, or I guess, how in space do you maintain a high-performance compute rack in that environment?
I know, it sounds like pure science fiction. But if you look at the macro constraints we just talked about, it actually becomes a logistical necessity.
How is it a necessity?
Earth has a massive bottleneck problem. The power grid simply cannot handle the gigawatt demands of these next-generation AI training clusters.
Yeah, and we are seeing intense local pushback.
Yeah.
One of the reports quoted the Texas governor recently, warning that data center firms have basically dug their own grave by ignoring local community opposition to these massive, noisy, power-hungry facilities.
Right, you can't just drop a gigawatt data center in a quiet suburb without literally crashing the local grid and angering everyone.
Right.
Space solves the land dispute, and more importantly, it solves the power generation bottleneck. In orbit, you have access to unfiltered 24/7 solar energy.
Okay, the power part makes sense. But what about the heat?
Ah, yes.
Everyone knows servers run incredibly hot. If space is a vacuum, there's no air. Convection doesn't work. You can't just point a big fan at a server in space to cool it down, because there's no atmosphere to carry the heat away.
The thermodynamics are definitely the hardest part of the engineering here, which is exactly why the hardware teams are so focused on these Vera Rubin NVL-72 racks.
What's special about them?
Elon Musk recently noted that these racks are being heavily modified for orbit. Because you can't use air cooling, like you said, they rely entirely on closed-loop liquid cooling.
Okay, but how does a closed loop actually shed the heat in a vacuum?
So the liquid absorbs the heat directly from the chips, right? And then it pumps it out to these massive external radiator panels on the exterior of the satellite.
Okay.
Those panels literally radiate the heat away as infrared energy into the deep freeze of the cosmic void.
Oh, wow.
Yeah, it's counterintuitive because space is an insulator. But if you increase the surface area of the radiators enough, infrared emission becomes highly efficient.
That is fascinating. But what about the physical density of the hardware? Putting weight on a rocket is wildly expensive.
Very expensive.
So how do you justify the launch costs?
Well, that's the beauty of the NVL-72 architecture. It packs 72 distinct GPUs working together as a single massive computer. And they're connected by copper backplanes instead of traditional networking cables.
So it's super dense.
It's incredibly dense and very heavy on Earth. But in a zero-gravity environment, the structural supports needed for that weight become irrelevant. The real cost right now is just the launch itself. Analysts actually estimate it will cost about 4 times as much to run compute in orbit today compared to a server farm in Texas.
Okay, so wait, if it costs 4 times as much right now, why do it?
Because Musk and NVIDIA believe that math will flip in the next 5 years. As Earth's energy grid maxes out, the cost of terrestrial power will skyrocket, while the cost of heavy lift launches via Starship will plummet.
Okay, let's talk about latency, though.
Okay, yeah.
If the server is in low Earth orbit, maybe 500 kilometers up, it has to beam the data back down to a ground station. The speed of light is fast, but routing through the Starlink network adds jitter, right?
Absolutely.
For training a model, latency probably doesn't matter much, but for real-time inference, like, asking a chatbot a question, that delay is a huge problem.
Which is exactly why the consensus in our sources is that orbital data centers will primarily be used for asynchronous tasks.
Like what?
Like training new foundation models, processing massive batches of scientific data, or running those long, complex agentic workflows we discussed earlier, where you really don't need a millisecond response time. You can wait a few minutes for the result.
I mean, I will believe it when I see a functional server rack floating successfully in orbit without melting itself.
Fair enough.
But speaking of highly coveted hardware, there is intense drama happening back down on Earth right now. Nvidia is in full production of its Grok 3 LPX chips, and the demand is so high that literal international smuggling rings are getting involved.
It's like something out of a movie. Seriously. 9 people, including an Nvidia manager, were just indicted in Taiwan for attempting to smuggle 74 of these AI servers into China to bypass U.S. export controls.
The fact that people are risking federal prison for server racks really highlights how critical this specific silicon architecture has become to the global economy.
Yeah.
But it's really important to clarify what they were actually smuggling here.
Yeah.
The Grok 3 LPX isn't designed for training massive models. It is strictly an inference accelerator.
Right. And we touched on this earlier, but let's draw a hard line between training and inference for a second.
Good idea.
If I'm understanding this inference chip correctly, it's kind of like switching from a massive freight train to a fleet of bullet trains.
Oh, I like that.
Like a freight train is great for hauling a massive load of cargo across the country slowly, right? That's training. But a bullet train is about moving a small amount of data back and forth incredibly fast. And that's inference. That is exactly the dynamic. Training is establishing the billions of parameters and synaptic weights over months of crunching raw data. Inference is just running a single user query through that already established network to generate a response instantly.
So why does inference need a completely different chip architecture? Like, why are these smugglers after the Grok LPX instead of standard NVIDIA GPUs?
It comes back to the memory bottleneck we discussed earlier with output tokens. Standard GPUs are highly parallel processors. They have massive compute cores, but they rely on high bandwidth memory, or HBM, which sits slightly apart from the main processor.
Okay.
So every time the GPU predicts a word, it has to reach across the chip, fetch the data from the HBM, and bring it back. That travel time creates latency.
But, I mean, it sounds microscopic.
It is microscopic.
Yeah.
But when you are generating thousands of tokens a second, those microseconds compound into very real, very noticeable delays.
Ah, gotcha.
Grok approaches this entirely differently. They don't build GPUs, they build LPUs, language processing units.
Language processing units.
Yeah. And instead of using external high bandwidth memory, an LPU embeds static RAM, or SRAM, directly onto the chip itself, right next to the compute cores.
Oh, so the data literally doesn't have to travel.
Right. The memory and the compute are practically interwoven. This allows for deterministic execution.
Meaning what, exactly?
Meaning the chip knows exactly how long every single operation will take, so data flows through it like water through a perfectly engineered pipe system without any traffic jams.
Which explains the crazy performance metrics we are seeing. The Grok 3 LPX is offering a 4x boost in response times compared to traditional architecture.
And if we tie this back to the beginning of our depth dive, you know those agentic workflows where the AI has to loop 100 times to complete a task?
Yeah.
Speed is everything there. If an agent takes 5 seconds per loop on a standard GPU, 100 loops takes over 8 minutes. The user gets bored and leaves.
Right.
But with a 4x boost from an LTU, that task finishes in 2 minutes. The speed of the hardware literally dictates the viability of the software.
It is literally a modern gold rush, complete with the outlaws.
Truly.
But let's bring this macro technology back down to the human level, right? With models getting cheaper, smarter, and incredibly fast, how is this actually impacting normal jobs? We've got new demographic data from Indeed showing which cities and professions have the highest AI job exposure scores.
Yeah, and the regional divide in this data is stark. The exposure scale goes up to 100, right? And the national average across all professions is 44.
Okay.
But the major tech hubs are sitting way above that baseline. San Jose is at 59, Seattle is at 57. Washington, D.C. and San Francisco are right behind them.
Wow.
The data basically confirms what economists have been warning about for a year.
Yeah.
Jobs built heavily around software development, data analysis, and digital knowledge work are the most highly exposed.
Okay, let me jump in and ground this, because I know people hear the word exposure and immediately panic, assuming it means their job is going to just vanish tomorrow.
For sure.
But exposure does not equal replacement. It means the specific tasks that make up your day are going to fundamentally change.
It's an incredibly important distinction. An AI can write a Python script or, draft a quarterly earnings summary incredibly well, but the data shows it struggles immensely with cognitive synthesis.
Okay, define cognitive synthesis in a corporate context. What does that actually mean?
It's the ability to navigate a messy, probabilistic environment.
Messy how?
Well, code is deterministic, right? It either compiles or it doesn't. But deciding which feature to build based on conflicting user feedback, a shrinking budget, and an erratic CEO, that requires human synthesis. AI lacks the situational context of the real world.
Which is perfectly illustrated by the other end of the Indeed dataset, honestly. The physical, hands-on trades are the safest jobs in the AI era. Plumbers, electricians, HVAC technicians, nurses. You cannot prompt an AI to crawl under a house and fix a leaking copper pipe.
Exactly. It's a classic example of Moravec's paradox.
Remind me what that is.
Moravec's paradox is this idea in AI research where high-level reasoning, like playing chess or writing a legal contract, requires surprisingly little compute. But low-level sensoromotor skills, like walking up a flight of stairs or turning a wrench, require massive computational power and wildly complex physical robotics.
So the economist's advice in these reports is extremely practical. A high exposure score is simply an early signal to adapt.
Yes.
Just let the AI handle the deterministic tasks.
Yeah.
The coding, the drafting, the data sorting. So that you can focus on the messy human synthesis.
Which serves as a perfect pivot, actually.
We're to it.
Since the data shows our daily tasks are inevitably changing, let's talk about how to proactively adapt your tasks right now. Let's get into our actionable AI productivity hack for the weekend.
Yes. I want to focus on a very specific, honestly annoying problem that almost everyone in a corporate environment faces. Let's say you need an interactive dashboard, a project tracker, or just a simple internal website to manage your team's workflow.
Right. And the traditional options for that are terrible. You either submit an IT ticket and wait 3 weeks for a developer to be assigned, or you try to maintain a chaotic shared spreadsheet that inevitably breaks the second someone sorts a column incorrectly.
Exactly, the spreadsheet nightmare. So we are looking at a new workflow that bypasses that entirely using the newly updated ChatGPT desktop app. What is the setup here?
The setup is incredibly minimal. You just need the ChatGPT desktop application installed on your machine. Once you open it, you switch your interface over to the Codex tab.
Okay, so I am looking at the interface now. I see the Codex tab. What's the next step?
On the left navigation panel, you'll see a specific option labeled Sites. Click on Create New Site.
Got it.
This opens a blank canvas. Now, instead of writing code, you just type in a natural language prompt describing exactly what you need, just as if you were giving instructions to a junior developer sitting next to you.
Give me a practical example of a prompt for this. Like, what would I actually type?
You could type something like, create an interactive project tracker for my marketing team. It needs to include a table with task owners, dynamic deadlines, color-coded priority levels, and a drop-down filter to sort by the status of the project.
So I'm just describing the UI and the logic I want in plain English.
Exactly.
How does it actually work under the hood, though? Is it just writing raw HTML and handing it to me?
It's far more advanced than that. The Codex engine translates your natural language into modern front-end frameworks, typically React components. But more importantly, it maintains state.
Maintains state?
Yeah. It spins up a sandboxed execution environment right there in the desktop app, renders the code, and gives you a fully functional interactive preview of the site instantly. You can click the buttons right away.
That's crazy. But I mean, it's rarely going to be perfect on the first try, right?
Oh, it almost never is perfect on the first try. And that's where the conversational aspect becomes powerful. You look at the generated site in the preview pane and you just talk to it.
And give it feedback?
Yeah, you say, okay, this table works, but I need a visual dashboard at the top showing only the overdue tasks, and make the overall design look a little more modern with a dark mode option.
And it injects that new logic into the existing code without breaking the whole thing.
Right. The LLM acts as the state manager. It updates the document object model in real time based on your feedback.
Okay, it's time for a skeptic check. Because this sounds slightly too easy.
I knew this was coming.
What is the catch here? I'm assuming this is not going to replace actual software engineers. What happens if the site breaks? And more importantly, what about security? If I tell it to track my team's projects, is it just hallucinating a database connection?
Okay, those are the critical guardrails we need to establish. First, no, this is absolutely not replacing software engineers. You are never going to use ChatGPT sites to build a secure, customer-facing banking application or an e-commerce checkout system.
Good. So what is the actual boundary of its usefulness?
It is strictly for lightweight internal tools and rapid front-end prototyping. There is no real back-end database connection happening here. The data you input into the tracker is usually just stored locally in your browser's local storage, or it's a lightweight temporary state.
Okay.
If you refresh on a different computer, the data might not be there unless you specifically configure it to export to a simple CSV file.
So it's basically a highly interactive, custom-built calculator or visualizer, not a persistent enterprise application.
Correct. It's for when you have a messy local process and you just need a clean interface to organize it today without the headache of provisioning servers, setting up databases, or begging IT for resources.
Right.
Once you refine the preview, you hit publish, and it generates a live shareable URL hosted on their secure domain that you can just Slack to your team.
That's super fast.
Yeah. And if a button stops working 2 days later, you don't need to dig into the code. You just open the chat history and tell it, hey, the filter button stopped working, fix the logic, and it rewrites it.
Okay, I can actually see that being incredibly useful for bypassing the IT backlog for very simple temporary projects. So here's my weekend challenge for the listeners. I want you to spend 30 minutes this weekend building a personal dashboard using this tool.
What's a good low-stakes use case to try for someone who's never done this?
Honestly, keep it entirely personal and simple. Build a chore tracker for your house where your kids can click a button to check off what they've done, or build a simple expense visualizer for a personal side hustle.
I like that.
The goal isn't to build a company-saving app, right? The goal is just to get a tactile feel for what it is like to prompt a user interface into existence using natural language.
I think that's the perfect entry point. It really demystifies the whole process. And hey, if you're going to try that weekend challenge, make sure you take a second to hit subscribe to the AI Verge so you don't miss next week's practical workflow breakdown.
All right, let's bring it all home with a crisp recap of the stack we covered today.
Sounds good.
Looking at the macro picture, the biggest takeaway from the economic data is that artificial intelligence is getting significantly cheaper and highly specialized. You do not always need to rent the most expensive, generalized supercomputer to get your daily work done.
Absolutely. And for our radar item, keep a close eye on the logistics of space-based compute. The engineering challenges are massive, but it really might be the ultimate workaround for Earth's maxed-out power grids.
And finally, for your action item, take 30 minutes this weekend and try the ChatGPT site's workflow we just outlined.
It'll change how you think about software, I promise.
That is the signal through the noise this week. But before you log off, I want you to think about the broader implications of that Thomson Reuters story. If a single law firm can build a bespoke model that actively outsmarts the multi-billion-dollar frontier labs in their specific domain for a fraction of the cost.
Yeah.
Well, what happens to the AI market when every single Fortune 500 company realizes their decades of messy internal domain data is actually vastly more valuable than the generalized algorithms we've all been obsessing over? Food for thought. See you next time.